Up to this point, we've been doing division with one-digit divisors. The reason for this is that we wanted to focus on the concepts involved with division rather than trying to teach a lot of mechanical operations. In theory, there's nothing new that happens when we increase the divisor to two-digit numbers or larger. In practice, however, this requires more patience and ability to work with larger numbers. Example, compute 72 divided by 12. If you have not memorized the multiples of 12, you're simply going to have to count them out. 12, 24, 36, 48, 60, 72. From this, we can see that 12 times 6 is 72, so that 72 divided by 12 is equal to 6. Notice that we wrote the numbers off to the side. This is known as scratch work. These are notes that are useful for us when we work through a calculation, but not part of the final presentation. It's important that you keep scratch work off to the side so that your final presentation is readable. You could think of scratch work almost like an outline for an essay. You use it to help you work your way through it, but in the end, it's not part of what you turn in. Example, compute 105 divided by 15. Once again, we're just going to have to work it out. 15, 30, 45, 60, 75, 90, 105. So that's 7. 105 divided by 15 is equal to 7. Example, compute 735 divided by 21. Do not be intimidated by the size of the numbers. We will follow the same logic that we tried to apply before. 21, 42, 63, 84, 105, 126. If we keep on counting like this, it will take us a long time to get to 735. So instead of counting by 21s, we will count by 10 times that amount, or 210s. 210, 420, 630, 840. Well, except that 840 is too many, so we need to stop at 630. 735 divided by 21 is equal to 630 plus 735 minus 630 is 105, so plus 105 divided by 21. 630 divided by 21 plus 105 divided by 21. 630 divided by 21 is 30, plus 105 divided by 21. If we look at the multiples we wrote down, we can see it's 5, so 30 plus 5. Final answer is 35. What would happen if we had a remainder? Conceptually, there's nothing different than what we were doing before. Example, compute 146 divided by 25. Start off by counting by 25s, 25, 50, 75, 100, 125. One more is 150, which is too much, so we'll stop at 125. 146 divided by 25 is equal to 125 plus 146 minus 125 is 21, so plus 21 divided by 25. Then we use the distributive property. 125 divided by 25 plus 21 divided by 25, which is 5 plus 21 25ths, or 5 and 21 25ths. Example, compute 6,000 divided by 250. How do you think we should proceed from here? We can work with the number 250, or we can cancel out one of the zeros and work with slightly smaller numbers. 6,000 divided by 250 is equal to 600 divided by 25. Working with the number 25 is not actually much easier than working with the number 250, except that there are fewer zeros floating around the page. If we tried to count by 25s to get up to 600, 25, 50, 75, 100, 125, 150. This will take a very long time. So instead of 25s, we will count by 250s. 250, 500. This is equal to 500 plus 100 divided by 25. That's 500 divided by 25 plus 100 divided by 25. And this is equal to 20 plus 4, which is 24. The goal of this section is not so much about doing division. In most real-life situations, if you were asked a division calculation with larger numbers, you would most likely have access to a calculator to do it for you. The primary purpose of this section is to show you how the ideas we've been developing can be extended to new situations. A secondary purpose of this section is simply to continue practicing working with numbers. Your ability to do arithmetic fluidly will greatly enhance your ability to follow the algebraic manipulations that will come in the future.